part F for question 7 for homework section 8.1. The problem I got was with a mu of 229 days and a standard deviation of 13 days. And part F wants to know, what is the probability a random sample of size 18 will have a mean gestation period within 10 days of the mean? So first, we know that n is 18, and we're given from the problem that mu is 229 and mu sub x bar is also 229. So since we have a sample size of 18, we're talking about the mean of x. So we have mu sub x bar and sigma sub x bar. To get sigma sub x bar, we need sigma divided by the square root of n, so I have 13 over the square root of 18. So looking at the standard normal curve that I've drawn, we have a mean at 229. If we want to know what probability we have for a random sample size of 18 for a mean gestation period within 10 days of the mean, I need to go 10 days on either side of the mean. So if the mean is 229, then I have 219 as the lower and 239 as the upper, and I want to know the area between those two values. This is 10 days within the mean. So I've set it up according to x bar, and we know we need to change our x's into z's. So I've got x bar set up 2 different times because I'm finding the area under the curve between 2 different values. So we take the upper value, the 239, and subtract the population mean, 229, and then divide by the standard deviation. And then that will give us the area from 239 all the way to the left tail. So since we don't want anything below 219, then we need to subtract the probability of z being less than or equal to 219 minus 229 over the standard deviation. So if I find the area from this value all the way to the left tail, and I subtract off the area I don't want, then I'm left with the area I do want between the 2 values. So if you type into your calculator each one of these, you should get a decimal that looks like this for each one respectively. Then to get the area under each of these curves, each of these standard normal curves, we need normal CDF. So I didn't write that down. So what you need to put into your calculator, if you want the area to the left of 3.26357, that is normal CDF negative 999 to 3.26357. Okay, and you can put this into your calculator all at one time. So normal CDF, these 2 values, minus normal CDF this time we're going from negative 999. Negative 999 is a sufficient value to represent negative infinity, so that's the left tail here. We're stopping this time at negative 3.26357. Okay, so that in the calculator, if you haven't done that already. We will practice that again. So if we turn it on and not drop it, clear. To get normal CDF, we hit second, and then we hit VARS to take us to DISTR distribution. We want a normal CDF, so you can either use the down arrow and then hit enter once you've highlighted 2, or you can just press the number 2 number. So from here, we're going to type in negative 999, comma, and then the decimal 3.26357, and close out the first normal CDF. Now we need to subtract, so minus. Get normal CDF the same way, second VIRS to take you to distribution. You can just touch the number 2 if you'd like. This time we're typing in negative 999, comma, negative 3.26357. Okay, and then when you get all that in your calculator all at one time, you hit enter, and it gives you the area under the curve, which you only have to have out to 4 decimal places, 0.99889, so that last 8 rounds up to 9.